Welcome to week 5, and this is going to be an example problem 4. The given information in this problem is a website reports that 65% of people are users from outside the United States. So this 0.65 represents the probability that you're not in the United States, and that 47% of their users log on to their website every day. So this 0.47 represents the probability that they log on daily. Suppose that 32% of their users are United States users who log on every day. So this is joint, where it's showing two events that occur. 32% is a probability that they're in the US and they log on every day. Now, we're asked to go through and find a couple solutions. The first of which is what percentage of users are outside the US. Now, given the probability that they're in the US plus the probability that they are not is equal to 1, and that's a complement rule which we can state in either of those two ways. Now, given that, it means that in this case we can just substitute 1 minus the probability that they are not in the US, which is 0.65, and then that result here shows you the probability that they are in the US, which is 0.35. Now, what type of probability is 0.32? It's a joint probability where it's, as the name suggests, it's two events that are joined, and you're given the probability of the two events occurring. The next part of the question wants us to construct a contingency table, and I am going to use my add-ins phstat, and I'm going to show you the power of templates in phstat with a caution that you absolutely have to understand what the templates or what the built-in formulas are doing. Now, if you notice, this comes with a bunch of data, and what it does, real briefly, it generates a contingency table for you. So let's call event B1 that they live in the US, and let's call this that they do not live in the US. This one, and if you notice, it fills in nicely the names for you once you replace the B1 and the B2. And A1 is that they log on every day, and this is that they do not log on every day. And let's go ahead and widen that. So what information do we have? This, as I said, the template, you have to be careful with it. A quick tip for phstat, it highlights in blue information that the template expects you to have as input. Now, we are not going to be using that, but I wanted to show you it would automatically calculate from those inputs the values here. If you randomly change this to something ridiculous, you will notice that the values are changing. So that's just a quick tip on that. So let's go ahead and change the way we're using this and remove all the information here. And if you notice, these are all reading from here, so they are giving you some weird results. But let's go ahead and fill in what we know. What we know for sure is that the probability that they log on every day and live in the US is 0.32. The probability that they log on every day was 0.47. And we also know that the probability that they're not in the US was 0.65. So these are the three pieces of information that you were given. Now the rest we're going to calculate using the various laws, the various principles of probability. First one is, if we did this in part 1 using the complement rule, where the probability that they live in the US is 1 minus the probability that they don't. So that was already found to be 0.35, but just to put the formula in, that's how it would be. This represents the total of the two events here, two joint events here. So this is going to be the difference between 0.35 and 0.32, because these two must add up to give you 0.35. These two entries here must add to give you 0.47. So this is going to be 0.47 minus 0.32, so that 0.32 plus 0.15 gives you this. The totals must always be, as it suggests, the totals of the entries it's representing. And again, this is going to be added to 0.15 to give you 0.65, so that means that has to be 0.5, and we can go ahead and compute these additions, and these are going to be the grand total, which is 1. Now if you notice, all of these cells, click on these cells on the Excel formula, look at what it is, read through what these are, and see that you understand what those mean, because this is an intelligent set of information which is calculated based on what you put in here. Now it's a good teaching tool, and it helps you to know how to build your own if you ever needed to. So that is the contingency table. Now real quick, part D, we wanted to find out the probability that a user is from the US given that he or she logs on every day. Recall this formula: the probability of B given A is equal to the probability of A and B divided by the probability of A. Now what we want to find is the probability that they are in the US given that they log on every day. It means we need to find, if this is A and this is B, we're going to need to find probability of A and B, which is US and they log on every day, which we know is 0.32, which is this value here. We also need to find the probability that they log on every day, which is the total for this section, for the log on section, so that's 0.047, which is here. So therefore the probability that they are in the US given that they log on every day is going to be equal to probability of US and log on every day divided by probability that they log on. Right, so looking at it now, this is probability of A given B, or in this case B given A. That means A is going to be in the numerator, which is going to be the probability that they log on every day, which is here. Now take a look at it, click on the cell as I have it now to see that you understand the substitutions here. I could have, and it would have helped, so I'm going to do it real quick. Type out what we have in terms of the probability of USA given that they log on every day is equal to the probability of USA and log on every day divided by the probability that they log on. Alright, so that's what this is in terms of B54 divided by B53. All right, it's a lot of information, a lot of details. Go through, click on the cells in the Excel document, and go ahead and do it. You could easily create this contingent table without using PHStat. So if this proves to be a little more confusing than helpful, feel free to go ahead and use and build your own table manually. But the fact that this does so many calculations for you can save you a couple steps, maybe not in this problem, but in others to come. So I wanted to show you both possibilities. All right, thank you for watching.